Good afternoon. In his book, Creativity, Inc., Pixar founder Ed Catmull talks about his early days in the computer design and graphics industry. And what he says is this: among the companies trying to solve those hard problems, most of them embraced a culture of strictly enforced secrecy. We decided to do the opposite, to share our work with the outside world. The relationships and the connections we formed proved far more valuable than we could have imagined, fueling our technical innovation and our understanding of creativity in general. So we think that Ed Catmull would have been right at home at Facebook Engineering. We also strive to share our ideas, our innovation, and even our software. This afternoon in this room, we're going to take you on a little journey. How do we build our apps? How do we work on performance? All the way through to deep dives on our data infrastructure and our developer infrastructure. But to start off, we have a session which I think many of you have been waiting for, to talk about React and Relay, and yes, React Native. It's my massive pleasure to introduce Tom and Jing, and first up, Engineering Director Adam Wolf.
Take it away. Thank you. Hi, I'm Adam Wolf, and together with Jing and Tom, we're going to tell you today about a couple of components that we originally built for web that are working really well for us on native mobile, React and Relay. And the reason why they're working well, we think, is because we designed them so that our apps would feel good. And what makes an app feel good is the same, no matter what platform we're talking about, web, native mobile, or even desktop. First thing you need if you want your app to feel good is basic reliability. And last year at F8, we talked about how React and the Flux architecture that we designed to go with it help us make our apps more reliable. And we gave this example of the unread indicator. If you have an unread indicator on your app and you go to it and you have no messages, that's really frustrating. And even worse is if you have unread messages and don't know it. And it's not too hard to get this right at first, but you have to make sure you don't break this as you update your app really quickly. And that can be tricky. But we think we've got a handle on that with these two architectures that we've built, with these two libraries that we've built. And I would say the next thing, if you've got reliability in hand, the next thing that you want from your app is you want it to feel fast. And if you're a developer like me, when you think about what makes an app feel fast, you might think about this. This is the instruments panel that we can use to debug slow-running iOS code. And this is a really important tool, obviously. You can use it to find a glitchy animation or figure out why your scroll stutters. And it's an important aspect of the performance work we do. But I don't think this is the most powerful lever we have to make our apps feel fast. And I tried to illustrate what I'm talking about when I want my app to feel fast with this little animation. So you can see here I have my phone, and it's got the usual bevy of Facebook apps on it, in addition to this cat pics app that I'm working on. So I'm going to launch it now, and I've got this cool little intro animation. And when it comes up, I'm going to start trying to interact with it. But it doesn't do anything until finally the images load and I'm able to scroll it. And the scroll lags, too, which is really annoying. And I don't know about you, but for me, I feel like this is the worst interaction I have with my phone. What is it doing instead of responding to my input? I feel like it should just do something. And I get so frustrated, I want to throw my phone across the room when this happens. And this is what I'm talking about when I'm talking about what makes an app feel fast. So I think the question we need to be asking is, how can we make our apps more responsive? And to answer this question, I think the other thing we can ask is, why are our apps unresponsive in the first place? How did we end up in this situation? And I want to illustrate this with an extended example of this cat picture app, this hypothetical cat picture app, and how it might do image loading. And I hope you'll stick with this long example because it's going to point out a lot of the ways, or a lot of the things we want from our general framework for loading and manipulating data on the phone. And to tell this story, we have a few actors here, right? We've got the server, because obviously we need to load these images from somewhere. And inside the phone, we have some resources that are actually highly constrained. That's what makes mobile challenging, right? Whether we're talking about web or native. There's the radio, and its access to limited bandwidth. There's the processor. Obviously, we're writing software. We need a processor. And there's memory, which is devilishly tricky to manage. We'll get to that a little later. And when we think about what needs to happen here, I followed the book, right? I have these images, they're objects in my UI thread. And the way I encoded this is like, we have this request we need to make, so we need to encode this request using the processor, and we need to send it to the radio, and that takes time. And then there's this long period of time where it's on the server doing something. It comes back, again, it gets blocked on the radio. And then there's this big decode step where the processor, sometimes the GPU, needs to turn these bits into an image until finally we can display it on the screen. And when I show it to you like this, it's like, yeah, of course it stutters. Actually, like, I'm surprised it works at all. It's pretty complicated what needs to happen there. But the reason why this app has this problem is because I encoded it wrong. And the mistake I made was to think of that image as an object. So we have a thing about quoting Dijkstra on our team. And I'm not going to read this because I'm not even sure he said it. It's attributed to him, but I don't know. But I think it's hilarious. And I think we can all agree that Professor Dijkstra would not like object-oriented programming very much. And frankly, neither do I. I think when you take the state in your system and you divide it up into these hermetically sealed boxes, you've precisely lost the ability to control how you orchestrate access to resources in that system. We want a different abstraction for thinking about how to program the user interface. And I'm going to drop it in here. And in this case, we're just talking about images, remember. I'm going to call it an image pipeline. And not by accident, there's a project that we're going to tell you more about that builds out this image pipeline for Android. So I hope you'll stick around in this room. But let's talk about what this hypothetical image pipeline might do. Now, what we want to do is we want to separate the concerns about how we fetch these images from their presence in the user interface. And what we're going to do is we're going to submit our requests into this image pipeline and then forget about them. And now we can interact with our user interface even while this process is going on in the background until finally we're called back with these loaded images. And if you're a web developer, you're out there like, congratulations, you guys invented the image tag. Good job. And it's true, actually, the web is pretty great in this way. It's got declarative interfaces for most of these things that we like. Although at the same time, the web is deficient in a lot of ways. One example here is that the complications of the box model and CSS mean that most browsers end up decoding images on the main thread. So if you're scrolling and an image comes in, it'll glitch. So even, no one really gets this right. And again, this is just images. But we actually have a much bigger problem than all that. We'll take the glitchy scrolling. We've actually caused a problem for ourselves because now we've made it precisely so that the user interface is no longer synchronized with this heavy lifting that needs to be done in the background. And now as a user, I can do something problematic. I can scroll this before any of the images have loaded. And you'll see at this point, I've flooded the image pipeline with requests, and it takes a little while for all these requests to come back. And this is actually a pretty big problem for our apps. And if you're watching this animation, you're probably thinking like, okay, we need to cancel those requests or reorder them somehow. And it's true, advanced image pipelines do have those features. But there's actually something more basic we need to do first, which is we can't forget about this work that we've done once we've done it. We need to drop in a cache here so that once we've made a request and it comes back, if we don't need that data right away, we have a place to put it. And this cache can actually get pretty complicated, right? We might want to segment the cache by product, or we might want to write a pretty sophisticated cache policy. And again, the web has an analog for this, partially. It's the static resource cache. If you've ever sent a 304 header from a server, you know what I'm talking about. And that thing actually doesn't have all the features we'd want, again. Like, you can't find out how big that cache is, or even what's in it. So you can't really write a cache policy like we'd want. So these components are pretty complicated, but they do solve this problem of responsiveness. The thing that we want to do now is bring it back to this general question of how we can build our apps so that they stay responsive. And everything I've just said about images really applies to rendering. If we had an asynchronous rendering pipeline, we could desynchronize what's happening in the UI from what's happening in the rest of the system. And if you've been following the React project for the last year, you know that this is exactly what React does. This is precisely the interface it offers. Last year at F8, we told you a little bit about how we think you should build a cache to go along with React, and we called it this Flux architecture. Over the last year, we've built a ton of Flux apps, and we've learned a lot about what makes Flux apps similar. And we tried to capture that in a library that we call Relay. Here to tell you more about Relay is Jing. Thanks a lot.
Thanks, Adam. So let's talk a little bit about Relay, what we think of as the next evolution of Flux, and what kind of problems it solves. As Adam said, we spoke last year about Flux, which provides a pattern for how actions flow through the system. But Flux didn't really specify how we get data from the server or how to organize data once it's on the client. A lot of this was very manually hooked up, and that led to some problems. We face the same problems on both web and mobile, but let's take this example from our website. The comment box on Facebook was one of the first projects to use both React and Flux, and it's also one of the most actively updated pieces of our UI. There's always multiple teams changing its behavior at the same time, and it's not always easy for them to add new features. So why is that? Well, we'll take an example. Stickers and comments were added just last year, so let's see what we'd have to do to be able to render stickers and comments. Here's how the component tree breaks down. We have a comment box component at the root, which renders a comment list, which renders a series of comment items. So what does this mean for our data? Well, we get our data from the server, which meant that the data needed to be passed from the top of the component tree to the bottom. So in this case, comment box would fetch data from a store, pass a subset of that to comment list, and then comment list would create a series of comment item components. In this case, each of the parent components needs to know about the data that its children needs, and it needs to make sure that it passes along the correct set of information. What this means, though, is that when we wanted to add rendering for stickers and comments, we couldn't just change comment item. We actually had to change its parent components all the way up the tree, even to the point where we were generating that data on the server. Now imagine that you have 3 different teams trying to make changes like this. They're all changing the same files, resolving conflicts, and worst of all, they're adding implicit dependencies that the other teams don't have context on. As you can imagine, it becomes hard to maintain this sync over time, and we were no longer confident at some point that we were only fetching the data that the render methods needed. So this version is just too manual and too fragile. What we realized is that the component was the right level of encapsulation for this. What we wanted in the ideal case is to only have to change the smallest component, and here that's the comment item component, in order to fetch the new data and update the render as well. Well, we already know that React components encapsulate rendering for themselves. With Relay, we wanted to go one step further and also put the specification for data in the component level. If we have the data query with the component, we no longer have to fetch all of the data in one place on the server at once. This makes it much easier to keep those 2 pieces, the query piece and the render piece, in sync, and it makes it so that you only have to change 1 file instead of 4 when you want to make a small change. In order to do this, though, Relay needed a common way of describing the data that a component needs that is a thin layer over any existing data model, and that's exactly what GraphQL provides. GraphQL is a data querying language we use at Facebook that was designed to describe the complex, nested data dependencies of our modern applications. So let's take a look at what the query looks like in practice. Let's say we're building this piece of a friend list. Here's what the data payload we want would look like. We want the ID so we can cache the object, the name of the person, the number of mutual friends we have, and some metadata about their profile picture. Well, what if we just took the names of all the fields in this data payload and kept the structure the same? If we remove all of the values, what we're left with is exactly a GraphQL query. The query itself expresses the structure of the data that you want from the server, and it's easy to tell just by looking at this query what we expect the server to give us back. Now, you might be thinking, this is a nice syntax for clients, but I don't want to rewrite my entire data layer in order to use this. Well, the good news is that you don't have to. GraphQL is meant to be a thin layer around your existing data layer, and it's just a way of presenting your data that's convenient for clients to use. All right, so now we have a way of specifying the data that we want. What about composition? Well, just as the render method for a React component can be composed of a tree of child components, the data query can also be constructed based on the queries of components that it renders. So with that, we have the query piece and the render piece as parallel pieces in the component. Even though they're used in different phases, one is used in the data fetching phase and the other one is used in the render phase, putting them both in the same component makes it easier to keep them in sync, makes it easier to make changes to a file. So now that we have both query and render in the same component, let's see what it looks like when we actually run this on the client. What Relay will do is take that data query tree and actually send it to the server. When we get a response back, Relay will break down that payload and store it in our cache of GraphQL data. And then it'll construct a set of props for the views to use. Now, this is pretty similar to the Flux pattern, but instead of having multiple stores that are specific to your application, Relay has one generic store that knows how to consume GraphQL data. Having a generic store allows us to implement common product logic, such as pagination, that otherwise products would need to implement over and over again on their own. So that's the read path. Relay also has built-in support for writes. When we want to show the results of an action to the user immediately before the server responds, we'll often construct what we call an optimistic payload to reflect the state that we think the server will be in. So when an action comes in with an optimistic payload, Relay can notify the views that are affected by the changes with a new set of props that reflect that optimistic state. Relay will also send a write to the server and get a set of updated data back from the server. And what it'll do is it'll merge that new data into its GraphQL cache. At that point, the components that are affected by the change automatically receive an updated set of props as well. This is pretty similar conceptually to how actions are handled in Flux, although Relay makes this whole process simpler by managing which views need to be updated and making sure that we can do things like roll back optimistic updates on errors in a seamless way. So now with this system, we get what we wanted to do in the first place. We can add stickers by changing a single component, rather than changing multiple locations of the stack. Here's a piece of what our original query fragment for rendering comments looks like. All we have to do to get stickers now is add attachments to the set of fields that we request from the server, and then use that data in our render method. This is so much simpler than the original version. Now we don't have to update 4 different files, we just have one. And rather than having implicit dependencies, all the logic for how to render and fetch data for this component is encapsulated in the component itself. Now, we were trying to solve this problem in the context of web when we started out. But actually, we faced the exact same problems with our mobile clients. And we could have implemented the same solution on iOS and on Android, but it's so much better if we could take a single solution and take advantage of it everywhere. And React Native allows us to do just that. And here's Tom to talk more about it. Thank you.
Awesome. Good job. Thanks a lot, Cheng. So we introduced React 2 years ago, and since then, a lot of you have probably been a part of this growth. It's been absolutely amazing to watch the growth. There have been plenty of talks about why we built it and how it works, so I'm not going to spend a lot of time on that. What I want to talk about today is why React has been so awesome for us at Facebook, and why it makes so much sense to bring it to mobile with React Native. First, let's talk about why it's awesome, though. React forces us to describe our views and break our applications down into components. And these components serve as the fundamental building blocks of those apps. And the views, in order to make changes to the entire system, in order to make changes to one part of our application, we don't need to keep the entire system in our heads. Sorry about that. But a lot of frameworks have figured out that components should be the fundamental building blocks of our apps. The thing that makes React great is that it wraps the DOM's declarative mutative API, or imperative mutative API, in a declarative wrapper. Now, when we talk about declarative programming, we're talking about describing what our program should accomplish instead of describing how it should accomplish it. Imperative programming, on the other hand, is focused on a series of steps that you should take in order to take what you have and turn it into what you want. So when we talk about declarative views, we're talking about describing what our application should look like at any point in time. What we found is that when we build using React's declarative components, we can actually move a lot faster, and it's actually a lot more fun building this way. So it's no surprise that React has been a home run for Facebook. And we're using it across all of our surfaces. And to be clear, no one at Facebook is forced to use React. Engineers are choosing to use React every day because it makes their jobs easier and more fun. And we're not just using it for demo apps and prototypes or internal tools. We're using it for real applications in production, especially Facebook.com. But up until this point, we've really only been using React to solve problems on the web. And these days, it's all about apps. With the web, we could build our applications using HTML, CSS, and JavaScript, and then deploy those applications or deliver those applications to any device that has a web browser, even some refrigerators. But with these applications, we have these independent, disjointed platforms that we have to learn and build on top of. This has effectively bifurcated our engineering organization. But that's just one of the reasons why native development is really difficult. Now, this isn't an exhaustive list, but I want to just go through a couple of reasons why native development has been a lot harder for us. The first one, and I think the most important one, is developer velocity. After every change that we make, we have to recompile our apps on native. On the web, we used to be able to just save our files and then reload our browser. But even if we want to move some text on the screen on native, we have to recompile our applications. So how many of you are familiar with this comic? It's an XKCD comic, right? A couple of engineers are slacking off, but that's OK because their code is compiling. Now, this is funny, and while we're not necessarily worried about engineers slacking off at Facebook, we are worried about the fact that they're moving a lot slower than they used to on web, especially in a code base that's as large as Facebook's. And it's not just engineers that are moving slower. If you want to run an experiment or run an A/B test, on the web, we push the site twice a day. You'll have the results of your experiment by morning. But on mobile, on native mobile, we have to release these apps. We don't release them nearly as fast. And you might have to wait a couple of weeks or a couple of months to get the results of an experiment back. Another thing that's really hard on native is you often have to manually size and position your views on the screen. And what this looks like is for a basic, this is just the code to generate a basic newsfeed story with 4 vertically stacked boxes. It's basically just a lot of imperative math, right? I don't expect you to be able to understand or read this code right now, but just understand it's a lot of imperative math. And this is fragile and it's hard to get right. On the web, we had something better. As much as we hate CSS, we hate the cascade, it was declarative and it allowed us to lay out our views declaratively, and then the system would figure out where they should be on the screen. On iOS, we have something a little bit better called auto layout, but we tried this. This didn't really scale for us. It wasn't fast enough. Another reason that native has been a lot more difficult for us is because we can't use the technologies that we're building for the web directly in the native environment. As Jing said, the problems that we've solved with Relay on the web, they're not specific to the web. Native mobile devices have these exact same problems. And in some cases, those problems are exaggerated because we have typically very high latency, low bandwidth environments on these devices. So the native environment, it's much more difficult to work with, and it slows us down. So why do we work with it? Why do we put ourselves through all this engineering and organizational pain? You can tell these are software engineers that are frustrated by the way that they're dressed, by the way. But why do we do it? Honestly, why do we do it? How many of you, raise your hand if you have an Android app or an iOS app? OK, let me count real quick. Everybody. Why? Why do you build Android and iOS apps rather than building for the web? Well, at Facebook, the reason we build native apps is because we can build better feeling experiences that are more consistent with the platform than we can with the web, at least for right now. And in the end, engineers are willing to endure a tremendous amount of pain in order to achieve that user experience. So at this point, what we've found is that it's effectively impossible to produce truly native feeling experiences with the web. But there are a lot of reasons why the native environment is actually better suited to producing those experiences. So even though it's harder to work with, there are a bunch of things that it gives us, a bunch of tools that it gives us that make it actually possible to produce these great feeling experiences. For one thing, in native, we have access to platform-specific components. There's currently no way to embed an iOS switch on a web page. And what we end up doing is we re-implement these components using HTML, CSS, and JavaScript. And we can do this. This is tractable, but it's difficult and it's cumbersome. And additionally, these components, as the platform changes, our re-implementations, they don't update automatically. We have to keep them up to date. Another thing that we have on native is the ability to parallelize work onto multiple threads. Let's talk about the threading model on the web. There isn't a threading model on the web, right? All of our application's code has to run on the main thread. And browsers will optimize this for us, and they'll do some image decoding optimizations and things like that. But we can't manually schedule our images to be decoded off thread, for example. We also can't do asynchronous text measurement and a bunch of other things. So this is probably one of the biggest challenges of building high-performance applications on the web. We also don't have anything as sophisticated as the native mobile gesture recognizers on the web. And we don't yet have the proper tooling or the developer discipline to build a system that gets this right. Nested scroll views are a lot harder to deal with than on-click handlers and on-mouse move. And we just haven't built anything on the web that gets this right as good as the native mobile environments do. So while there are a ton of downsides to building native apps, and we've given up many of the awesome benefits of building for the web, we can't ignore the fact that right now we can produce better-feeling user experiences on native. And a lot of people tell us we should just wait. Just wait, the web is getting better. We're going to have all of these features and more soon. Pretty soon, you won't even need React because the standard abstractions built into the browser are going to be just so good. But listen, we've been waiting. We've been waiting a long time. Shifting to mobile has really slowed us down, but at this point, we really know what we want. We want the great user experience that we get with the native environment, and we want the great developer experience that we get when we develop with React on the web. So let's talk about the current ways that we can get the best of both worlds. The first one is web views. Let's just use web views, and we'll wrap them in thin native wrappers. This will give us the ability to have push notifications and have an icon on your home screen, but it'll also give us the fast, rapid iteration cycle that we have with the web. Well, this is a great idea. We tried this. We built this. We called it FaceWeb, and while it didn't scale with our application size and with the growth of our team, we actually think this is the greatest developer experience because you get that rapid iteration, and you can use all of the great things that we have for the web. But unfortunately, since this is built using web views, we have to use HTML, CSS, and JavaScript. We can't produce those truly native-feeling experiences. The next idea we had was, what if we ported React to native? What if we rewrote React in Objective-C, for example? Well, we built this too. This is actually a great idea. So if you saw the talk yesterday, this project is actually called Components. And Components gives us all of the great benefits of React, especially our declarative, descriptive user interfaces. And it gives us all of that access to the native technology that we need, like we can do things off-thread. We can image decode off-thread. Additionally, Components, which was open sourced yesterday, uses Flexbox for layout. So that same code that I showed earlier with all that imperative math in it, it now looks like this. It's a lot easier to use and maintain. There's only a couple of minor downsides with this approach. For one, it's written in Objective-C, so it's iOS only. So if we want to take advantage of this system on another platform, we have to re-implement it on that platform. The second thing is that we can't, out of the box, take advantage of things like Relay, because they're written in JavaScript. So the platform just doesn't, we can't just integrate into, a components rendered view hierarchy with the data that comes from Relay. But the third thing that really stinks here, and I think this is the biggest thing, is back to my original point. This is written in native code, so we have to compile after every change. So we haven't fundamentally improved our developer velocity problem. So what it sounds like we want is the ability to combine these two techniques, right? We want to be able to write scripted code, but for a native environment. If we use JavaScript to script native APIs, we should have access to all of the great features of the native environment, but that rapid iteration cycle that we get on the web. We should be able to take advantage of some of our existing JavaScript infrastructure, like Relay. And we could probably make this stack work across platforms, since it's just JavaScript, and JavaScript is ubiquitous at this point. It sounds like everything that we want, and it's no surprise that there's a ton of frameworks out there that try to do this. But we tried those too. And unfortunately, while they're a step in the right direction, they didn't quite work for us. And the reason they didn't work for us is because scripting native is tricky. If we just synchronously call back and forth between native and JavaScript, our UI could lock up while we wait on JavaScript execution. This is exactly what Adam was talking about. So we know we need to parallelize our JavaScript. But parallelizing our JavaScript is hard for two reasons. The first reason is because of resource contention. If our JavaScript accesses something that might represent a resource on another thread, the system has to lock. if we try to measure a view that's rendered on the screen, for example, from a background thread, the system has to lock and get us that dimension. The other reason this is hard is because of the overhead that's associated with every single message that has to be passed between the native environment and the JavaScript environment. If we need to cross the thread boundary often, we have to pay this fixed cost over and over again. So if we do this wrong, this could make things a lot worse. Our application could end up feeling a lot worse than if we were to just build it exclusively in native code or exclusively in JavaScript. But the good news is we know how to solve these problems. We can solve the first problem by making our rendering async, right? We can, if we never synchronously access a resource from another thread, and we instead queue up the operations that need to happen, we can let the system take care of executing those operations whenever it can. And we can take care of this fixed cost of overhead by batching up as many of these messages as possible, and then delivering them all at once, as many messages as possible per frame, and delivering them all at once to the native environment. Asynchronous and batched. We think these are the critical components of this architecture. And the easiest way that we've found to get this asynchronous model is to describe our views declaratively. Describe what they look like at any point in time and let the system update them for us when it can. This is exactly the application model that React gives us, right? So React components are just pure, side effect-free functions of our application state. We never need to read from those rendered views in order to write to them. React is non-blocking with respect to the DOM, but the beauty of React is that it doesn't need to render to the DOM. It keeps our view system's logical hierarchy separate from the implementation of that hierarchy. So we can just as easily render to UIKit, for example. This is why it makes so much sense to bring React to mobile, and it's exactly why we built React Native. React was intentionally designed this way from the beginning. We didn't have to go in and layer on iOS and Android view systems. So React Native actually uses the exact same React that's on GitHub. The only difference here is that with React Native, we render in an embedded instance of JavaScript core, and we render to high-level platform-specific components like view and text, rather than running in the browser and rendering to divs and spans. Another really important part of React Native is that we can adopt it incrementally. We've learned at Facebook that incremental adoption is the key to success in large software systems. And React Native enables us to do just that as well. So just like we didn't need to convert all of Facebook.com to React in order to start taking advantage of some of the benefits that we get with it, we can adopt one feature at a time with React Native wherever and whenever it makes the most sense. Another thing I want to call out is that we're not chasing the write once, run anywhere pipe dream. These platforms have different looks, feels, and behaviors, so we should always be building separate, discrete apps for each platform. But we want engineers to be able to learn the technology once and then build for whatever platform they want. Another thing I want to call out is that it's not important at all that we're using JavaScript for this. JavaScript is just an implementation detail with a bunch of great side effects. For example, it lets us use relay out of the box. And most of what you'll see when you look at the GitHub repo for this is a lot of it is type checked with flow. So JavaScript just gives us a bunch of nice side effects, but it's an implementation detail. So enough babbling about architecture and implementation details. We've been using this internally at Facebook for a while now, and it's really working well for us. Everything I'm about to show you, I'm going to do some demos now, you actually have access to if you have an iPhone. I'll demo most of these apps in a minute. But the F8 app that you downloaded for this event, if you have an iPhone, this is 100% completely built using React Native. How many of you knew? Right? Our Groups app, that's also been in the App Store for a while now, is a hybrid app. And this consists of both React Native views and native views. So some of the views are written in Objective-C, and some of them are written in JavaScript. And the beauty of Groups is that it's actually powered, the entire feed is rendered using Relay. So we get to take advantage of both of these infrastructures. And the other app that we built using React Native is our Ads Manager. This app, it's a very, very complex app. There's tons and tons of screens. And it feels absolutely awesome. It was built by a bunch of engineers, some fantastic engineers, but those engineers didn't have experience with iOS or Objective-C. They were able to build this app in record time, and it feels great, again. But the best part about that team is that the same team, after they shipped this to the App Store, turned around, and now they're building the exact same app for Android. The same engineers. What we found is that the best people to build products are the people who understand that product. So they should be able to build that product on any platform that they want. So now I'm going to give some demos. The first demo I want to show you is on an iPhone. There it is. So first, I'll just real quick, I'll go through the F8 app. For those of you who've used this, you've already seen this, but we have like sticky headers on the left. I'll jump into one of these sessions here. You can see this, this detail view that comes up. That animated kind of view at the top, that animated header, it's all powered by JavaScript, all of this. You see these great animations and navigation animations? No one can tell that this isn't native, because it is native, but it's 100% written in JavaScript. Let me jump over to our Groups app real quick. I have a bunch of my groups here. I'm going to dive into my family group. My family's been talking. And again, here's a photo of me and my dad. And everything you're seeing on the screen, this is all 100% built in JavaScript. I can focus this comment box here, my mom leaving a little comment about the 4th of July. And again, this is a hybrid application. So some of these views are written in Objective-C, and some are written in native code, or in React Native, sorry. The next app, I'll just quickly show a demo of this Facebook Ads Manager app. So here's all of my ad campaigns. And I have a list here. I have some popovers. I can filter a bunch of different ways. I'll dive into one of these. We'll look at website clicks. Down here we have a graph. Actually, let me grab another campaign that has a nicer graph here. I can look at the performance of this ad set over the course of 7 days, over the lifetime of it. And I have these gestures, these native gestures. I know you can't see where my fingers are, but I have these native gestures. It's a completely native app. And if I go over to the settings page here, you'll notice there's an in-app sound switch. I can switch that on and off. And that's a native iOS switch, everything you'd expect. So the next demo I wanted to show is Android. We weren't able to get the display working, so I'm hoping that we can kind of let you see it right here. All right. So this is pretty low fidelity, so if you want to come over to the open source booth after this, you can play with this in person. But here's that same app, but it's running on Android, and you'll notice a couple things. I mean, there's a create button in the bottom right. This is a material design construct. We don't have that on iOS. There's no tab bar on Android, though. So if I dive into one of these campaigns here, you'll notice that we didn't get that slide over animation that we have on iOS. That's an iOS construct. On Android, we have a different transition. I can hit the hardware back button, which again doesn't exist on iOS, and go back to this home screen. I'll slide out my Android drawer here, and then I'll jump over to the settings page. And another thing you'll notice here is I have that same switch, but the switch is actually an Android switch. It's not an iOS switch. Sorry, I'm incapable of doing this on stage. But yeah, so that same switch, it's not an iOS switch, it's an Android switch. These are Android components. This is a different app, but being built by the same set of engineers. So now I'm actually going to jump to my laptop. I'm going to write some code. Switch over to the laptop for me. Oh, great. So on the left here, you have the iOS simulator running, and on the right, I just have my text editor. So what we're going to do first, we're looking at that same exact Ads Manager app. I'm going to go in here, and the designers came back, and they said, you know what? Our advertisers need to be able to see their creative a little bit bigger. Can you make the photos larger? So I'm going to come in here, and I'm going to change the size of our image container. I'm going to change the width and height to 60 pixels. I'm going to hit Command-S to save the file. I'm going to Alt-Tab over to my simulator, and I'm going to hit Command-R. And just like that, we have bigger photos. Thank you. So the next thing they wanted, they noticed a lot of apps are using circles these days instead of squares. So I'll just real quick, border radius. We're going to just round these corners off. Oh. Interesting. Invariant violation. Border radius is not a valid style property. I guess I spelled it wrong. So I'll just fix that, save it, and reload. Awesome. Thanks for calling that out, though. But what I wanted to demonstrate there is that one of the things people love about React is it tells you when you do something wrong. We shouldn't have to dig into logs to see that. We should be able to look right at the thing that we're looking at and see our error messages right there. So now I'm going to do something a little bit more interesting. I'm going to go into my Ads Manager results summary here, and I'm actually going to go down here to the end where we're fetching queries using Relay in GraphQL. This is a GraphQL query, and what I want to do here is I want to actually fetch some data that we weren't previously fetching. So I'm going to add in here the run status info object, And from that, I'm going to fetch the activity status description. If I come up here above where we're returning this thing, in my render function, I can create a status object. I added some snippets here to make it easier to type. And you'll notice that results node.runStatusInfo.ActivityStatusDescription is the exact same thing that we started fetching here. So results node.runStatusInfo, activity status description. Now we'll just, in our render function, we'll just output that next to our subtext. I'm going to add a little spacer here. And then I'm going to come back over here and I'm going to refresh. See that little active that showed up right there? That is data that was not previously being fetched when I previously loaded this app. And now Relay has enabled us to fetch that new data. You can't see this very well. We can add some text around this. We can add a component. But that data literally wasn't there before, and now it's modified the whole GraphQL query, and we can show that stuff. This is the developer iteration cycle we want. This is the developer flow that we want. We want to be able to save our files and reload our editors. I'm going to switch back to the slides. So, this is working for us. This is really exciting. The demo is fun. We'll have more demos at the open source booth. But I'm not up here to claim that we've solved software once and for all, right? I'm just here to tell you that this is working for us. We're really happy with it, and we're confident that this is the right programming model and the right approach to building all of our applications, both web and native. The developer experience improvements here that we've observed, not even that we're speculating about, that we've observed, are just absolutely awesome. But we want feedback on it, and we want help making this as good as we possibly can. So that's why we open sourced it this morning. Cool. Again, we're looking for your feedback. We really want contributions on this. We don't want everybody to change their development style right now. We want you to help us out. Help us build this out and make it as good as it can possibly be. The thing that I want to close with is this point. Okay? Facebook does not hate the web, but we're realists. We just can't use the web right now to build the types of user experiences that we want. The day that we can, the day that the web is good enough, I assure you we will use it. I cannot wait for that day. The day that it is good enough, we will use it. But until then, we will use this. Thank you very much.
So as you've noticed, we're running a little bit late. The next session, which is a deep dive into our Android products, will start in exactly 10 minutes. So 10 past 1. See you there. Thank you, everyone.